Direction cosines of a line. If we have any line in space, we can move that line parallel to itself and we can fix the line at the origin of a 3D coordinate frame. Now if we do that, let the line makes an angle alpha, beta and gamma with the x-axis, y-axis and z-axis respectively. Then the direction cosines of the line will be represented by the symbol L, M and N and are defined as cos alpha, cos beta and cos gamma respectively. Now we have two very important results about direction cosines of a line. First is sum of the squares of the direction cosines of any line is always 1, like I have proved it here. Let's say the line has endpoints at O and P. P is in a space, coordinates are x, y and z. So if we drop the perpendicular from, this will be x and x can be written as OP cos alpha. Similarly, if it was y-axis, we will get y equals to OP cos beta, and if it was z-axis, we will get z equals to OP cos gamma. If we square and add, we can see that this OP square is nothing but x square plus y square plus z square, and both will cancel, and hence we will get L square plus M square plus N square. For two parallel lines in a space, clearly alpha, beta and gamma will be same, and therefore direction cosines will always be same.